There's some huge advantages to being able to go into a dry dock and inspect the propeller. Normally, they would have to take that propeller off. That's a day of work, load it up on a truck, send it to a specialist, get it back a week later, mount it back on the ship. Well, now we can just do a lot of that process right in-house in the dry dock. You look at how things were done traditionally, and you just see that there's kind of this big opportunity where there's a lot of costs and a lot of people with their hands in it, from the dry dock to the riggers to the specialists. If you can pull that in-house and have one or two guys who are able to just 3D scan the prop, it pays for itself usually in one or two jobs.
This is Greg Trauthwein with Maritime Reporter TV, and we're very pleased to be joined by Adam Kaplan, the CTO of TrueProp Software, to discuss his team's advances in propeller inspection and repair, and how the TrueProp virtual bundle provides all of the equipment and the software needed to help bring propeller repair into the digital age. So, Adam, to start us off, can you just give us a brief professional background with insights on your role today at TrueProp?
Yeah, thank you, Greg. Appreciate the time here. So my name's Adam Kaplan. I'm the CTO of TrueProp. I degreed mechanical engineer from the University of New Hampshire. I did my undergrad there, and then I did my master's degree there. And during that time, I was actually interning with Hydrocomp Inc. With Don McPherson and Jill Aaron. And a couple of years came around, and we had an opportunity to kind of do something outside of Hydrocomp scope, which is the propeller inspection side. So Hydrocomp, where I worked, it's traditionally a software company. There's not a hardware component. And getting into the physical aspects of propeller inspection for both manufacture and repair required us to kind of make a spin-off company. So me and Jill Aaron, we founded TrueProp Software in 2015, late 2015, early 2016. And in the beginning, it was really just like a part-time thing that we did a couple hours a week to kind of develop the product, right? And we were working with Gary Linden Propeller. He had built this propeller scanner, and he needed to interface it with a computer. So he needed to basically digitize the signals, and he needed software to kind of guide his customers through scanning propellers and repairing propellers. So kind of got to rewind a little bit. When I was at the university, we used a system called digital image correlation, which we were pulling pieces of metal, tension specimens, and you would videotape that, and it would track how the metal deformed. And I was, through using that system, I was realizing, oh, well, these stereo cameras are, in order to track deformation, every single picture it takes, it's making a 3D model. And before I left UNH, I actually did a test where I set up the system above a propeller, shot down, and captured the surface. And it was just back then, it was just an exercise in curiosity, really. It was something, propeller geometry was something I was interested in. I was doing a lot of propeller CAD work through Hydrocomp. And so that was kind of the first seeds of the TrueProp virtual solution that we'll hear about a little bit today. But basically, we were capturing the geometry of the propeller without even touching it. So, that equipment was hundreds of thousands of dollars, right? Very expensive for a university, no problem, right? But it wasn't something that you could use in the field or anything like that. And as kind of tech with these handheld 3D scanners progressed from those ARM-based hexagon scanners and Faro scanners to like these handheld units, and the price came down tenfold. That really made this non-contact inspection process possible. And it actually, we were previously using traditional machines, interfacing them with a computer, but this really gave something novel for people to use, a new tool, a new process that's even arguably more effective and has a lot of advantages for shipyards and stuff like that.
You already kind of given a kind of a short overview of True Prop. Can you give an overview of its offering to the maritime
Yeah,
market?
yeah, absolutely. When we initially launched, our primary focus was existing propeller inspection equipment. So typically and I actually got a little model one right here. I'll grab it off the shelf. Typically that's a drop rod based system here. So propeller mounts here. You've got an axis here that measures the radius, and then you've got another axis here that measures the drop. When the propeller sits on this and turns, we're measuring the angle. So we can pull any coordinate off the blade surface. And that's the equipment that we traditionally worked with, right? Uh, we looked at the sensors in their equipment. We figured out how to get those signals into the computer, set up the software for them. That was the main product, was the software piece, and also the interface that goes in between it. Out in the wild here, there are a number of commercial machines, and they go back. They go back to 1920, 1930. Some of them are really, really old, and a lot of them don't even have any digital equipment on them. So the primary product is software, and then we got into retrofitting these older machines, uh, both with the software piece and the digital connection, the sensors that you need to detect position. And then, from there, we were actually uh, working with Gary Linden to sell new machines as well. So Gary has this hydraulic prop press system. It's great. It's got an integrated scanner that goes on the top. You can check the propeller. If something is not in tolerance, then you can go and make adjustments with it hydraulically. So uh, basically, we're getting into more and more propeller repair equipment. Uh, in 2017, we launched what we call TrueProp Virtual. So this was for people who had 3D scanners, and our first customer was really a consultant working for the Coast Guard. And what he had was a Creaform Handy Scan Black Elite, a really top tier handheld 3D scanner, blue light laser. Uh, and what he would do is he would go into the dry dock and he would scan their propeller where it's at. He'd get the 3D model, and then we would go and pull data out of it. So then we just automated that process using TrueProp to basically, instead of pulling it from physical sensors on a drop, a radial, we call them a pitchometer, but it's basically a coordinate measuring machine. It's just a polar system. So instead of physically probing the prop, we started to 3D scan it. You bring it back to the office, load it up in the software, get your report, all your diagnostic screens, and you can understand right there where the propeller's damaged. So this was, again, originally developed for a kind of one customer, the Coast Guard. It was a joint industry project with a couple companies who were interested. And out of that came our TrueProp Virtual product. So this was great. People who had 3D scanners, they could bring their propellers into TrueProp, get reports, understand things. But we were getting consistently asked for a whole package. Like, hey, I don't have any 3D scanner or computer or anything. I need everything. I need the software. I need the scanner, all that. So when you get into blue light 3D scanners, there's 100 options, starting from $500 up to $200,000, $300,000 for these systems, depending on really capabilities, speed, all that stuff. Through like a lot of trial and error, we narrowed down on a product that was really perfect for marine propellers. And our criteria was that we had a certain level of surface accuracy we needed, but the biggest thing was, can you do this outdoors? Can you do it in sunlight? Can you do it in a dry dock environment? Because there's some huge advantages to being able to go into a dry dock and inspect the propeller. Normally, they would have to take that propeller off. That's a day of work, load it up on a truck, send it to a specialist, get it back a week later, mount it back on the ship. Well, now we can just do a lot of that process right in-house in the dry dock. So people were looking to do that, and they just didn't know where to start. So we found Shining 3D offers some scanners that are really very capable at a great price point for our market, for our target customers. And it's a very scalable solution. So we have an entry-level model called the HX2 that we offer with our bundle. Great for propellers up to 80 inches. I mean, people use it for outboard propellers. People use it for larger propellers. I've seen people do 120-inch propeller, down in Panama. So that one is the entry level one, but it's still very capable. If you're doing this all the time, you need more speed. You need basically a bigger capture area. So that's when we got to the FreeScan combo. So TrueProp Virtual plus the FreeScan combo, which is this scanner right here. And you can actually see just how portable this system is, right? It's just a small briefcase. I can take this as a carry-on on the airplane, fly down to the dry dock, go right there. I got my equipment. And really, at that point, all I need is a high lift or some scaffolding or something to access the prop. And we can take the model and fly home and analyze all of it. That scanner can do props up to 2.5 meters. We kind of say 160 inches. So, but the real difference between those two is really about how fast you can capture it, because so the scanner has more laser lines and a wider field of view, can just capture. Think about like how long it would take you to paint the surface with a roller. If you have a small roller, it takes a long time. You got a big roller, less time. So now today, we are working on offering our third package, which is going to be essentially an even wider field of view. I mean, the customers that we're selling this to are typically boat builders or shipyards. One of them is scanning a 35-foot boats, wants to do tuna towers and cabin layouts, wants to check shaft alignment, and also wants to do propellers. So this is called the FreeScan Nova Track. There's a tripod system with the scanner. There's a handheld scanner. You move your scanner around, that tripod is tracking where you are. So it's kind of like two scanners, really. It's a very cool system. And again, the price point from where things were even 5 years ago is multiples less, which makes this extremely viable for our industry. It's getting to the point now that these packages, TrueProp Virtual with any one of these scanners, is actually more affordable than the traditional probe-based equipment that people are currently using. And that's led to tons of interest from the Coast Guard, the Navy, U.S. Army, propeller manufacturers, and now we're seeing a lot more movement on the shipyard side as well.
This question, I think, is a bit basic, but just kind of set the stage. Can you just discuss the importance of the propeller to not only just the vessel's drivetrain, but the vessel's overall performance, and then specifically, if it's damaged or warped from its original spec, what are some of the problems that can result?
The propeller is the driver of the ship. It takes the power from the engine, all that potential, and puts it to the water. And without a good propeller, you're going to have poor efficiencies. You're going to be burning extra fuel. And that's just talking about the right propeller theoretically, right? So when we spec a propeller, it's matched to that engine, that vessel, that mission, and it has a particular diameter and it has a particular pitch. And that pitch value is really critical to the performance. That's the number that, when you impact something and you bend the blade, you're changing that angle, which is changing the pitch of the blade. And what happens is, if the pitch of each blade is different, think about flying an airplane with one wing at a slightly higher angle than the other wing, right? The plane wants to tilt like this, so you'll be fighting it to get back. It's going to be the same thing on the propeller blades. As they're going around, you got one that's pitched up at a higher angle. The loading on that blade is is stronger. The hydrodynamic forces, the thrust, all that stuff, it's flying essentially like an airplane wing at a higher or lower angle of attack. So what's going on there? Now you have higher loading on one blade, and what about these other ones? They're the same. So you get, as it's rotating around, you have a heavy loading. You're getting a pressure pulse every rotation. So that's kind of speaks to the importance of having blades that are well matched. You want take the pitch, the numeric pitch value aside. You want those blades to be as similar as possible, because that is going to be most efficient. But also, when you have that pressure pulse going by, that's how you start to get your vibrations. So you think about the prop going by, boom, boom, boom. Let's say you have two blades that are different. You get a high and a low. So you start to get this cyclic frequency. And that is a major thing that people notice after a strike, a propeller strike, right? You hit something, you damage your prop, all of a sudden the boat's shaking. And so, okay, initially it's just a shaking or whatever. It's not a huge issue, but all that vibration is propagating up the drive line. You got eccentric loads on your prop. Now you've got eccentric loads in the cutlass bearings, up through the drive line into the engine mounts. Things are shaking. You can even get superstructure damage after a while. That's kind of where TrueProp comes in, is it gives us a way to measure each one of these blades and make sure that they are the same angle, pitch value. And also for like post sea trial performance, like we spec a propeller, it gets delivered, it gets put on the ship, the boat goes out. Sometimes there's a disconnect between the design theory and actual real life performance, right? So we may need to go in and make some adjustments to the propeller. Like, for instance, let's say the engine cannot get up to its rated RPM. We're rated for 1800 RPM. We're getting 1675 RPM. So we're 125 RPM short. The engine manufacturer won't warranty that engine. So we need to go and make an adjustment to lighten up the propeller so that it can spin up to 1800 RPM. We can get that 125 RPM back. So we'll send it out to a specialist. They'll measure it, see where it is. They'll say, it's this pitch value. We got to take out 2 inches of pitch from the blades. This lets them, one, figure out where the propeller is. They measure it. They know what the spec, what the physical pitch of the propeller is. They know what the design pitch should be. So if there's a discrepancy there, they can correct right there. But also, if they need to take out pitch to get RPMs up, now they can bend the blades and remeasure them. And they can ensure that each one of those blades is the same, so that that propeller goes back on the boat. It runs smoothly, it runs efficiently, and they can get their speed up, their RPM up, burn less fuel, and get their engines warranted, all that good stuff.
When a vessel comes in with a propeller problem, what are some of the traditional ways in which it's fixed?
A lot of times, this will be outsourced to a specialist. So the boat comes out, they start painting or whatever, they'll pull the prop off and put it on a pallet. Well, that takes a union crew of guys and maybe 1 or 2 days and supervisor, and then they load it on the truck. You pay for the rigging, you pay for the transport, it goes to the shop, and they will use these traditional tools. Typically, they'll mount the propeller on a mandrel and drop a probe on the surface and check the heights of all the blades, match the pitch. They'll polish it up and put it back on the truck, send it back, and there you go. Like 10 days later, you have your propeller back to go mount it. They may not have even had to make any pitch adjustments, because you just don't know when you're looking at it. So you could have pulled that prop off, sent it out, and reinstalled it, at crazy costs, just for them to basically polish it up for you, grind the barnacles off. Because, if it's a routine maintenance, there may not be any damage to fix. So this is where, the kind of the cost savings comes in, right? If you can leave that propeller on, do your inspection there, you see there's no damage, you can just clean it up, polish it right there. You save yourself a couple days of work. You save yourself tons of labor costs, both from outsourcing that, the transport, the installation and deinstallation. So you look at how things were done traditionally, and you just see that there's kind of this big opportunity where there's a lot of costs and a lot of people with their hands in it, right? From uh, the dry dock to the riggers to the specialists. Um, if you can pull that in house and have one or two guys who are able to just 3D scan the prop, I mean, it pays for itself usually in one or two jobs. It's that much of a paradigm shift from what people are doing. Um, so, and let's say you scan it and there is some damage. Well, now you can hire that specialist to come out. They can do the repair right there. A lot of them have particular tools that they can, do something from scaffolding, whether it's small stuff we can use hammers, sledgehammers, but larger stuff we'll have to use some like hydraulics. But that's a real opportunity to save both schedule and costs from the traditional approach.
We've discussed true prop and its role in helping make propeller repair more efficient and more effective. So specifically looking at the two major groups targeting in this interview, looking at the shipyard and looking at the boat owner, how
Mm-hmm.
does true prop assist the shipyard or propeller shop to work more efficiently? And then how does that then deliver to the ship and boat owner a propeller fix that's more effective?
Yeah. Let's start with the ship owner, because I think that's really that's the end goal, right? You want to make them happy. Uh, you want to make them satisfied with your repair work, so they keep coming back. Um, the ship owner, as far as they know about the propeller, they know that it's maybe in some condition that's not great, and they want it restored to the best condition possible. So they want a really high quality repair, and they want that proven to them, right? They want some document that they can point to that says, here's how it was, here's what we did, and here's how it is now, and it's better for these reasons. It's also great to have some historical document about the propeller's condition. So let's say you do run aground and have a propeller strike, you say, hey, this is what it was before, can you fix it back to this, or can I get a new one made to these specs? So from their perspective, they're looking for documentation and proof that the repair has been performed properly, that the condition of the propeller is improved and all that. So that's TrueProp really helps with that, because what it does is it takes the data of the propeller, whether that's drop gauge data or whether that's 3D scan data, it takes that and it generates the tolerances, and it documents all this in a report, a single page document or multiple page document, whatever they want. Um, and it gives them all those numbers, that historical reference that they need. It's kind of like when you bring your car in to get your tires balanced and aligned, right? You go in, you don't know how far the alignment's out, you just know something's up. You bring it in, they print out, they give you one report that shows, hey, your alignment was, toe out or cambered or whatever. They give you the final report that shows you, hey, we adjusted it. Look at all these little green boxes. Everything's in spec now. And you walk away knowing that you got your money's worth on your repair. So I think that's the analogy that works well for this. You have your propeller, it's damaged, document the condition, fix it, document the repaired condition, give me the proof in paper. Now from the shipyard, that's going to TrueProp as a solution. One, it lets them achieve that goal. It lets them generate the documentation from the propeller's condition. It's a computerized report, so it provides a really high quality document with a lot of integrity. You can't really trick a 3D scanner, right? You're getting a full 3D model of it, pulling it into the computer. The algorithms are doing all the work. There's not a lot of human element. The traditional approach has a guy with a probe, going down. I'm not saying he's not an honest guy, but if it's an eighth of an inch off, and it's up to him to write it down on a spreadsheet, I don't know. There can be there can be motivation to take the easy way out. So one, TrueProp as a solution for shipyards, it gives them the ability to do this work, and it also lets them do it cost effectively and with some advantages on reducing schedule and overall costs. And it allows them to bring these capabilities in house so they can advertise that. Um, so that's all good for the end customer.
Hey, just kind of speaking on the investment side,
Mhm.
what specifically is the investment in time and resources, training on the software to get
Yeah,
TrueProp up and running at a shipyard or a propeller repair facility?
true. Yeah. So when we bring a new customer on, a lot of times that is not without a demo first. When you go through one of our demos, it's a lot like this. There's a lot of explaining. There's a lot of examples shown. It's almost like a mini training. So we always recommend that people sit through that. Uh, when we deploy the software, if they're purchasing a scanner, they're getting training from Shining 3D, which is the manufacturer of the scanner. We also do a 4-hour training session with all purchases. A lot of that can be done remotely because we're really focused on the output of the scanner. But it's amazing that these handheld scanners are so easy to use. In an hour or so, you have the basics down. You can start to capture geometry, and getting more effective with that. There's a number of strategies. We've outlined a lot of those in video tutorials, webinars, things like that. So the resources are there for you to find the information yourself. But we work really closely with our customers to ensure they're successful. The first 30 days of the purchase include technical support and program updates, and that just really ensures that we get them up and running successfully. So I usually hold their hands right through the first report, all the way through their first 3D scan. They pull the data in. We go through the diagnostic screens. Hey, here's what you're seeing. This is what that means. Here's some suggestions on maybe correcting that issue that you're seeing. Here's the report that you can provide to your customer. Hey, we got the first one in the can together. Now you'll go do one yourself. Maybe you'll have questions and reach back out to us. But it's amazing that people have been able to get up and running with this, with 4 hours, 5 hours of training.
Can you share a couple specific examples, providing as
Sure.
much detail as you're allowed, that illustrate the value of TrueProp?
Yeah, absolutely. I mean, I think there's some of the pictures that we'll provide to you is one that we did recently in November. And it was our largest scan that we did personally. Now, our customers have done larger ones, but this was one that we did personally. In Portsmouth here, where I live, there's an old submarine called the Albacore. So this is like the first teardrop hydrodynamic sub design from the 1940s or something like that, and then really heavily used in the 50s and 60s as the Navy's premier test bed. And it's a propeller driven submarine. I believe it was a nuclear powered submarine also, and it might have been diesel. But either way, it had a set of contra rotating propellers on it. And it was actually originally deployed with just a single prop. So they were just retrofitting this thing in different ways, testing it out. Very successful program that now a lot of the other, the Virginia class and stuff all use this teardrop design, these flanking rudders and things like that. They've largely switched from, the propeller side to, like a water jet style system. But anyway, there's a museum in town here. They've got the submarine on display. You can walk inside it. Really cool local attraction. So we got in touch with them. We said, hey, we want to scan these propellers as kind of a case study. It's interesting because it's an old 1960s Navy design. It came out of Philadelphia. And it was used for a couple years on one boat, and then it was put on the Albacore, and now it's mounted in the park there as kind of a memorial. So we 3D scanned that thing. It's 15 feet in diameter, very big. We just had to use a ladder. So we showed up, laptop, ladder, 3D scanner. Like 2 hours, we were done. scanning everything in direct sunlight, all the conditions you would expect to make this very realistic and difficult. And of course, we were very successful because that's how the package is designed. And it was really interesting because when we were like looking at the prop, we could see like a bend in one of the blades right on the edge, like a little scallop. And 3D scanning it, we're like, oh, that area is going to show up on the report. Sure enough, like the propeller's perfect, and then right there's an area where the blade was bent, shows right up out of tolerance. And my guess is that when they were um, transporting this thing and rigging it and mounting it, when they lifted it up, it probably leaned down on that blade, and the 3,000 pounds of bronze just bent the blade. So that's just a really cool case study. One, it's interesting to see an old Navy design, something that's not classified or anything anymore, that you can actually publish the data for. And then to find like a little error like that, probably from handling. One, it speaks to the risks of transporting the prop and the rigging and all that we're trying to bypass, right? So if you get damage from just literally putting a prop on a dummy shaft in a park, what happens in a dry dock where it's crowded and all that other stuff? Like, what's the risks there? I think it speaks to that. And then the difficulty of doing it outdoors, with battery pack, laptop, all that kind of stuff, climbing up on a ladder, just a really realistic application. So that's something we can share with you guys, and lots of video from it. And I'll be doing actually a presentation in town here to kind of just tell people about a little bit about what we do, and also I think you talk about the digitization for historical records and stuff, particularly for like a museum. The propeller's gonna be 75, 80 years old. How much longer is it going to be sitting in the park? At what point do we want to have a digital version, in the computer, for the future? And that's something that we provided to them, and little 3D printed models and stuff like that too for fun. So yeah, that's a great case study. I think it really speaks to the power of the solution.